Assalamu alaikum warahmatullahi wabarakatuh. Okay, now last time we have done kinematics part 2 and part 1 previously we have done. So now today kinematics part 3. This is the last stage of this topic kinematics. Okay, so physics motion 1.2. After kinematics there is a chapter of forces. So in 1.2 the first topic is kinematics, and today this is kinematics part 3. Okay, now we have to start from distance time graph and then speed time graph. Okay, let's start. Okay, now in distance time graph now we will complete this topic in some points. So after taking different steps we will complete the topic distance time graph. So the first point is we always consider time along x-axis as it is independent quantity. Time never depends on other physical quantity. Okay, now distance along y-axis. So you have to remember first point. Always consider time along x-axis and distance along y-axis. Okay, like this. We consider time along x-axis with a unit second and consider distance along y-axis with a unit meter. So always consider time along x-axis and distance along y-axis. Okay, now we are talking about distance time graph. So the second point, a line parallel to time axis or x-axis always represents stationary state of rest. So a straight line parallel to x-axis represents state of rest or stationary state. A straight line parallel to x-axis represent state of rest. So no movement, no change in position, right? Like this. This line is parallel to time axis or x-axis. It means no further distance is going to cover, right? No further distance is going to be covered. It means okay, but a line not parallel to x-axis and not parallel to y-axis represents something else. But before it now, we have to learn what is a gradient of a line in distance time graph. Okay, the third step, the gradient of a line. What does gradient mean? Gradient mean an inclination of tangent. Okay, so this is tangent theta, and tangent theta is equal to opposite upon adjacent. Opposite meaning to say vertical, adjacent horizontal. Sometimes we consider a gradient is defined as rise upon run, but basically gradient meaning to say an inclination of tangent. So inclination meaning to show an angle. So tangent theta, the angle is theta and tangent theta equal to gradient. Okay, so it means the rise or the vertical distance y2 minus y1, horizontal distance x2 minus x1. So gradient of a line is y2 minus y1 upon x2 minus x1, and these y2 minus y1, x2 minus x1 represent or consider from 2 points. One point is x1 y1, other point is x2 y2. So we can calculate gradient, right, by dividing vertical distance upon horizontal distance, and distances can be obtained by taking difference along y-axis and along x-axis. As we know, distance is defined as the difference between 2 points. So vertical distance, the change in y2 minus y1, horizontal distance, the change in x2 minus x1. Okay, now the gradient of a line in distance time graph represents speed. So it means, what is the gradient of this line? If a line parallel to time axis or the x-axis, so it has no inclination, it is just parallel to x-axis, so theta would be 0 and tangent 0 degree equal to 0, right? So in other words, if we consider over here y2 minus y1, so no change in vertical distance, so both are the same values. When same values are subtracted, we always have 0 magnitude. So 0 divided by x2 minus x1 will give you 0. Otherwise, you should learn by heart what the gradient of a horizontal line is 0. And the gradient of vertical line is undefined, as tangent 90 degree is undefined. Okay, so listen, the gradient of a line represents speed. So it means in distance time graph, if we are going to find out a speed, not for this line, some other lines. So speed equal to y2 minus y1 upon x2 minus x1. Yes, y2 minus y1 upon x2 minus x1. This is the gradient of a line, represent speed. Or we can write also y2 minus y1 is rise, x2 minus x1 is run. So rise upon run or opposite upon adjacent. If we are able to draw a triangle, okay, then we can use these words as well. What? Opposite upon adjacent. Okay, now listen over here, the gradient of a line, distance time graph represent speed. Okay, now if a line is straight, we can find out the gradient like this. If line is not straight, then we can find out the speed at given point by taking tangent with the help of chord, according to the senior examiner. Okay, now I will explain. So first point, second point, third point. Okay, we are talking about straight line. If a straight line is parallel, okay, straight of rest. But a straight line is not parallel to axis, AXES axis, meaning to say both x and y. If a line not parallel to x axis and not parallel to y axis, then we are able to find out speed, or we are able to find out the gradient. Otherwise, I have told you, gradient of a horizontal line 0, gradient of vertical line is undefined. Okay, it is not possible. Okay, time will stop. If time stops, we are unable to do anything else, right? Time never stops. Okay, now let's say point number 4. A straight line not parallel to axis. This means plural, both x and y. A straight line not parallel to axis, not parallel to axis, but line is straight. It represents it represents uniform motion or speed. So a straight line not parallel to axis, it represents uniform motion or speed, and uniform motion or speed meaning to say equal distances covered in equal interval of time. So no change in speed or constant speed, uniform speed, constant speed. So the graph of this straight line like this, a straight line, sometime passing through origin, sometime does not pass through the origin, it's okay. But remember, it must be a straight line, it must be a straight line, and we observe motion from this point. Already object is moving with some speed. Then otherwise, if I started to draw a line from origin, so an object with a uniform speed from rest. Okay, now listen. A straight line not parallel to axis, it represents uniform motion or uniform speed, constant motion, constant speed. Now it must has a gradient. So the gradient of a line represent speed in this condition. So it means we can find out this speed by taking 2 points on the line and then divide vertical distance between these 2 points and horizontal distance between 2 points. Okay, now for example, if I consider 2 points, point A is over here, point B is over here. So what is the vertical distance between these 2 points? This one. This is the vertical distance between these 2 points. What is the horizontal distance between these 2 points? This one. This one is the horizontal distance between these 2 points. So this is rise, this is run, rise upon run. Or if I consider an angle over here, so opposite upon adjacent. So we can find out the speed with the help of graph by taking 2 points and make such calculation. Then we will be able to find out uniform speed or uniform motion. Okay. The next point is number 5. If a line is not straight, it is a curved line. So if graph represent a curved line, okay, curved line, a curved line in speed time graph, in distance time graph, a curved line in distance time graph represents, a curved line represents variable speed or variable motion. Variable speed or variable motion. But listen, there are two cases. Variable speed either increasing or decreasing. If speed is increasing, so larger distance is covered in the same interval of time. There is an increase in the distance covered for the same time duration. Then speed is increasing. But if distances decrease in the same interval of time, for the same interval of time, distances decrease, then this is decreasing speed. Okay, on graph, how we will represent this thing? Like this. Listen, time axis in second, distance in meter. Okay, now listen, if we are talking about this one, this is the curved line. Okay, it is going to be parallel, this line going to be parallel to x-axis. Okay, now suppose it is going to be parallel to x-axis. So if a line going to be parallel to x-axis, it shows decreasing speed, decreasing motion, right? Decreasing speed or decreasing motion. How? Listen, a curved line, a curved line going to be parallel to time axis or x-axis represents, a curved line going to be parallel to x-axis represents decreasing speed, represent decreasing speed. How? Listen, okay, in equal interval of time. Okay, I consider equal interval of time like this. This is equal interval of time. Okay, now in equal interval of time, these are, suppose these are equal interval of time, then what is happening here? In the first step, how much distance covered? This distance is covered. Okay, in the second one, this distance is covered. In the third one, this distance is covered. So there is a decrease in distance covered in first 5 seconds. Suppose 5, 10, 15. I consider in first 5 seconds this distance is covered. In the next 5 seconds this distance is covered. Okay, in the third, fifth second this distance is covered. So for the same interval of time, the distance covered is decreasing, distance covered is decreasing. So there is no equal distance is covered in equal interval of time. It is not uniform speed. Okay, now in the topic number 5, variable speed. So I've told you there are two types. If distances decreases for the same interval of time, so it means an object or vehicle slows down. Vehicle is slowing down. So speed decreases. Speed decreases. Okay, now listen. A curved line going to be parallel to x-axis represent decreasing speed. Is it clear? Okay, now the next one. Second part of point number 5. A curved line going to be parallel to y-axis. Okay. A curved line going to be parallel to y-axis. A curved line going to be parallel to y-axis. Okay, how listen? Like this, going to be parallel to y-axis. Now this is time axis in second, distance in meter. Okay, so a curved line going to be parallel to y-axis, it represents increasing speed. A curved line going to be parallel to y-axis represents increasing speed. Okay, now check for equal interval of time. The distance covered is increasing or is decreasing. Okay, now check. Consider equal interval of time like this. Okay, now in the first 5 seconds, this distance is covered. For the next 5 seconds, this distance is covered. And for the next 5 seconds, this distance is covered. Okay, now it is very clear. In the first 5 seconds, a small distance is covered. Next 5, more than this one, right? And next, more than this one. So it means larger distance covered with increasing interval, equal interval of time. So when the distances are increasing for the same interval of time, so an object become speedy. Moving object increases its speed. Okay, so a curved line going to be parallel to y-axis, it represents increasing speed. It represents increasing speed like this. It is clear. Okay, now so we have done 5 points here. We have done 5 points. Point number 1, how we consider axis. Point number 2, a straight line parallel to x-axis or will represent state of rest. Point number 3, for any line, the gradient of a line, if it is straight, so gradient of a line, it is curved, the gradient of a line at a specific point will represent gradient. The speed will represent speed. The gradient of a line or a point on a curved line represent speed. Okay. Point number 4. Point number 4. If a line not parallel to axis, it shows a straight line. A straight line not parallel to axis shows uniform speed, uniform motion. A curved line shows variable speed, and there are 2 types of curved line. Line going to be parallel to x-axis, decreasing speed. Line going to be parallel to y-axis, increasing speed. Okay, now speed time graph after distance time graph. The first point as it is, what? The time is in dependent quantity. So time is taken along x-axis and speed is taken along y-axis. Time is taken along x-axis and speed taken along y-axis. Like this. Time in second, speed in meter per second. So time is considered along x-axis, speed is considered along y-axis. Time is considered along x, speed along y. Okay, now the next point. If a line is parallel to x-axis in speed time graph, it represents uniform speed. But the same line on distance time graph, it shows state first. Okay, remember over here on line parallel to x-axis or time axis. So a line, a straight line parallel to x-axis represents a straight line parallel to x-axis represents uniform speed. Okay, but in distance time graph, a uniform speed can be represented by drawing a straight line but not parallel to x or y axis. Remember, over here, a straight line parallel to time axis in a speed time graph, it represents uniform speed or uniform motion. Uniform speed or uniform motion. This is the second point. Okay, now the point number 3. Point number 3. Okay, so the gradient of a line over here, speed time graph, represents acceleration. The gradient of a line in speed time graph represents acceleration. And we know that the gradient meaning to say an inclination of tangent theta, or opposite upon adjacent, or rise upon run. So one can write down y2 minus y1 upon x2 minus x1. Okay, now the gradient of a line represents acceleration. So we can write down acceleration would be equal to y2 minus y1 upon x2 minus x1, or we can write down rise upon run, or y2 minus y1 upon x2 minus x1. Now listen, this formula I have mentioned in point number 4, distance time graph. But over here, point number 3, why? Point number 4, for a straight line not parallel to x-axis, not parallel to y-axis. So in distance time graph, always there is a line with positive gradient. Always it happens, positive gradient. But there are two straight lines, one with positive gradient, one with negative gradient. Okay, what does it mean? Listen, if a line has an inclination from 0 to 90 degree, it gives you positive gradient. But if a line with an inclination between 90 to 180 degree, it gives you negative acceleration meaning to say deceleration or retardation. Okay, listen, point number 4. Okay, this is the point number 4. A straight line not parallel to axis. Yes, not parallel to axis. Not parallel to x-axis, not parallel to y-axis. A straight line not parallel to axis represents represents uniform represent uniform acceleration, either positive or negative, represent uniform acceleration or deceleration, or one can say retardation as well. Okay, so a straight line not parallel to axis represent uniform acceleration or deceleration. How? Listen. Over here two graphs. This is part A, this is part B. Okay, listen. If find like this, okay, what there is an angle smaller than 90 degree. If I draw a line like this, there is an angle greater than 90 degree. So if an angle with x-axis is smaller than 90, it shows positive acceleration or simply acceleration, right? This is uniform acceleration. Okay, or you may proceed it like this and then consider this angle as well. Okay, now listen here. If we increase this line, so this angle, same thing over here, no? Right? These two angles are equal, these two are equal, corresponding angles. Okay, so if an angle with x-axis greater than 90 degree, it shows uniform deceleration for a straight line. So write down over here uniform deceleration or uniform retardation. So a straight line will show acceleration. If gradient is positive, simply acceleration. Gradient is negative, so it is deceleration. So it has negative gradient, it has positive gradient. Okay, so for negative gradient, an angle greater than 90 degree, right? Positive gradient, an angle is smaller than 90 degree. Okay, so uniform acceleration, uniform deceleration, but simply uniform acceleration, right? This is point number 4. This is point number 4. Okay, now point number 5, and we will talk about curved line. Okay, this is point number 5. A curved line represents. Okay, now we are working on speed time graph. A curved line represents variable acceleration or deceleration. Variable acceleration or deceleration or retardation. So curve line will show variable acceleration or deceleration. In distance time graph, curve line section is divided into 2 points: increasing speed, decreasing speed. Okay, but only for speed. But over here, increasing acceleration, decreasing acceleration, increasing deceleration, decreasing deceleration. Okay, rather than writing 4 different statements, I am showing you 4 different curves with A, B, C, D. Now listen, I draw 4 sections over here. This one, this is part A. You know, this is time axis and this is speed axis. Meter per second, speed in meter per second, time in second. Okay, along x and y, along x and y. So already I have discussed a curve going to be parallel to x-axis, meaning to say decreasing. So this is as an angle form over here smaller than 90 degree. The word decreasing along with acceleration. Over here angle is same, smaller than 90 degree, smaller than 90 degree. Okay, this angle is smaller than 90 degree, this angle is smaller than 90 degree. Okay, now but it is going to be parallel to y-axis, so the word increasing must be used, but for what? Acceleration. So this is increasing acceleration. Okay, both curve has an angle with x-axis smaller than 90. We must use the word acceleration. But this curve going to be parallel to x-axis. So this is decreasing. This curve going to be parallel to y-axis. Therefore it is increasing. Okay, now the part C, and this is part D. This is part C. This is part D. And now we will talk about deceleration. So an angle must be greater than 90 degree, like this or like this. Okay, to find out the angle, draw any parallel line that curve the curve. Suppose this angle greater than 90 degree, this angle greater than 90 degree, right? So greater than 90 we use the word deceleration or retardation. But what is the shape of a curve? It is going to be parallel to x-axis, going to be parallel to x-axis, meaning to show decreasing. We use the word decreasing. As the curve going to be parallel to x-axis, we use the word it is going to be parallel to y-axis. We should use the word increasing. Okay, this is for increasing, this is for decreasing. But what about the angle? The greater than 90, we must use the word deceleration. Okay, the curve going to be parallel to y-axis, the word increasing, but the angle is greater than 90 degree, we use the word deceleration. Okay, now one can easily remember this thing, now. How? Going to be parallel to x-axis, decreasing. Going to be parallel to x-axis, decreasing. Going to be parallel along y-axis, increasing. Going to be parallel along y-axis, increasing. Okay, increasing and decreasing. It shows the nature of curve. Okay, but an angle form over here less than 90, use acceleration. Less than 90, use acceleration. Greater than 90, use deceleration. Greater than 90, use deceleration. So 5A, 5B, 5C, 5D. Okay, now the last point is area under the curve or area under the graph. Okay, this is the last point. Okay, the point number 6. Point number 6. Area under the curve, area under the graph. Will show, area under the graph will show distance covered. Okay, under area under the graph. Sometimes there is a straight line. Okay, the area of triangle, area of rectangle, area of trapezium. Okay, but sometime area under the curve. Then we will calculate area under the curve by dividing the region into equal boxes and find out the area of one box, then multiplied with approximate number of boxes. Okay, but listen, area under the graph will show distance covered. Okay, now listen, this is the journey of a vehicle like this. First start from the rest, then with uniform speed, and then decelerate. Okay, this one is the area under the graph. This is the area under the graph. So this will show distance covered. This area will show distance covered, and we can find out the area under the curve. For example, if the shape is trapezium, right? Sometime triangular shape, sometime rectangular shape, or a shape is combining by triangle, rectangle, trapezium, there is a possibility. Okay, so different formula we must use. In mathematics, we'll discuss all this type of formula. Otherwise, I will write down in the last. Okay. So area under the graph will show distance covered like this, or listen, area under the graph, this will show how much distance covered throughout the journey. We can find out distance covered by considering the area under the graph, right? We can find out in this way. So this is area under the curve. Okay, area of a triangle, for example, we are talking about area of a triangle. So area of a triangle half times the product of perpendicular sides, and these two perpendicular sides known as base into height, base into height, or one can say area of a triangle half time product of perpendicular sides. Okay, now area of a rectangle, it is equal to rectangle, meaning to say two triangle. So when two triangles are added, half plus half equal to 1. Just write down length into height or length into breadth. Length into breadth or length into height. This is the area of rectangle. Okay, what is the area of trapezium? Area of trapezium. What is the area of trapezium? Okay, area of trapezium meaning to say half time sum of parallel side times distance between parallel side. Half sum of parallel side. For example, if I draw a trapezium over here like this, so this length is A, this length is B, this is H. So half time the sum of these two parallel sides, half times sum of these two parallel sides multiplied by distance between them, right? So shortest distance between them or displacement. In this way we can find out area under the graph, and area under the graph represents how much distance covered during a journey, right? This shows how much distance covered during a journey. Okay, now we have discussed distance time graph, then speed time graph, and I did not try to confuse you, right? So I used simpler words, right? Simple steps in a sequence so that you can compare and interpret distance time graph and speed time graph. Okay, now we have done all these things. One thing that I have told you, okay, we will discuss what or how the graph of free fall motion we can describe. For example, terminal velocity only terminal velocity. Okay, listen. Once again, terminal velocity we have defined. This is the uniform speed in a gravitational field, or this is the uniform speed under the action of gravity, or this is the uniform speed for free fall motion. But I have cleared there should not be any factor like wind blowing or some other changes in pressure and something else if we are talking about gravitational field. So gravitational field meaning to say in our gravitational field there is existence of gases that is known as air. If the air is stationary and object is launching in upward direction, it must fall with the same point. If we are talking about limited time, as we know that the earth is rotating, okay, so it means ignore other factors, then uniform speed is the terminal velocity when object performs free fall motion. But right now only about graph. Now listen, this is speed, this one is time. Okay, a parachute is jump from helicopter that is hovering at a certain height. So when a parachute is jump, what happened? Start from stationary state, state of rest, and then move down with a uniform speed or variable speed. Move down with a variable speed. How? When a person is moving down, so with the time, the speed increases. There must be gravitational acceleration. If we use the word the object is falling with a uniform speed, what does it mean? It means no acceleration, no gravitational acceleration, zero gravitational acceleration. So how we consider gravitational field? Okay, so when an object is moving down, so speed increases or speed decreases. Okay, listen, object is moving down, a parachute is jumped from a hovering helicopter. So what happened? Speed increases with decreasing rate. Speed increases with decreasing rate, right? Speed increases with decreasing rate, like this. Yes, like this. Okay. So if we are talking about gravitational acceleration, maybe there is a gravitational field, so there is air but stationary. Okay, so like this. Otherwise what happened? Moving like this as well, uniform. But I'm showing, I'm telling you, gravitational acceleration is changes. Gravitational acceleration changes. Okay, from 10 to 9, 8, 7, 6, and then what happened? This time in real, it will become parallel. Become parallel to x-axis. If this line become parallel to x-axis, then what does it mean? Uniform speed. Okay, over here, listen, this is point A. This point is B. This point is B. This point is C. This point is C. Okay, so from A to B, variable speed. Okay, variable speed, so it is moving towards, or it is going to be parallel to x-axis. This is decreasing acceleration, so gravitational field changes. Okay, gravitational field remains same, but the value of g changes due to existence of air. Okay, when speed increasing, air friction also increasing. In this way, with increasing speed, opposite forces increases and the value of g decreases. Value of g decreases. So this is not decreasing speed, this is increasing speed but decreasing rate, so decreasing acceleration, decreasing gravitational acceleration. Okay, so this show decreasing acceleration. Over here, uniform speed. Now at this stage, parachute is open, the parachute, surface area increases. Surface area increases, what does it mean? A more air pressure will exert. Now more air pressure will disturb. Increasing surface area, pressure increases, more air pressure will hit the parachute, and what happened? Speed at once decreases. At once decreases. So downward there is deceleration and going to be parallel to x-axis, decreasing deceleration, increasing deceleration, uniform speed, decreasing deceleration, again uniform speed. Over here it shows uniform speed once again. This point is D, this point is E. So from A to B, decreasing acceleration. What is it? Terminal velocity at high speed. What is it? Terminal velocity at some lower speed. Higher speed terminal velocity, lower speed terminal velocity. So this is higher speed but terminal velocity. Okay, this one deceleration, decreasing deceleration. This is decreasing deceleration, and this one is lower speed terminal velocity. Lower speed but terminal velocity. Okay, lower speed This speed less than this one, but it is the constant speed showing a straight line parallel to axis. This showing a straight line parallel to x-axis. Okay. A to B, decreasing acceleration. B to C, high speed terminal velocity. So uniform speed. C to D, decreasing deceleration. D to E, lower speed terminal velocity, but uniform speed. Terminal velocity meaning to say uniform speed. So there are two stages of terminal speed. That's why that time I was telling to you. It's okay. Now we have completed kinematics, whole kinematics through part 1, part 2, part 3. Okay, now listen. If you like my video and previous video, subscribe my channel, share it, like it and comment. Allah Hafiz.